While acknowledging the cost premium and limited energy capacity, flywheels are complementary to batteries, serving roles requiring instant response. The flywheel principle, an ancient concept, demonstrates how a spinning mass stores kinetic energy. High strength-to-weight ratio, advanced material, performance optimization.
Turbomod. These visualizations highlight the primary loss mechanisms. Bearing drag and air friction.
By creating a vacuum inside the enclosure, we eliminate air resistance and reduce windage, leading directly to a dramatic enhancement in efficiency. Contactless suspension eliminating friction, revolutionary technology, wear elimination. Frequency regulation, responding in milliseconds to grid fluctuations. The fastest response, a truly premium service.
While the battery charges slowly for long duration, the supercapacitor provides a faster onset. In the event of a utility failure, our system provides an instantaneous and seamless transition.
close-up of wind farm integration, smoothing output fluctuations, renewable support, and variability management.
Through effective ramp rate control, we moderate rapid changes. This ensures grid compliance and contributes significantly to stability.
Shot of cycle life. Millions of charge-discharge cycles possible. Endurance capability. Wear resistance.
Depth of discharge. Without damage, unlike traditional batteries.
This modular design allows for multiple units, providing flexible architecture for scaling capacity and power across the entire system.
The New York Flywheel project, 20 megawatts for grid regulation, utility scale deployment, market participation. The high capital cost established this facility, but the economic profile is defined by exceptionally low.
Understanding the total cost of ownership is crucial. It includes the initial purchase price, ongoing maintenance, and eventual replacement costs. Showcasing flywheel advantages, incredible power density, and robust strengths. Ultrasound inspection. X-ray analysis.
The new composite shows significantly less drag at high speeds.
And the advanced bearings are handling the heat distribution flawlessly. Site preparation involves a reinforced concrete foundation. The structural support frame is lowered by crane.
This side-by-side comparison clearly demonstrates the advantage. With a 75% smaller footprint, according to the tablet, we need to slide this module closer for the optimized configuration.
All right, let's align it now and secure the connection.
.93. Wide view of grid interconnection, same requirements as other storage, regulatory framework and standard process.
Utilizing advanced system support and black start capability, we rapidly isolate the fault and synchronize the grid.
A true historical precedent, these electric buses stored energy in a rapidly spinning flywheel, offering quiet urban transport.
From its roots in the 1990s, grid computing has seen a modern revival, driving market emergence and innovation.
The European markets are dipping, but persistence is key.
The new tech deployment is holding the line. We have validation.
This is the sustainability advantage. Green technology with clear environmental benefits, free of toxic materials or disposal concerns.
Through rigorous life cycle analysis, we minimize our environmental footprint. This sustainability
The new design protocols have drastically reduced the risk profile.
Yes, the safety record is impeccable.
Proven safety through proper design.
As the FMEA shows, the fracture initiated due to stress corrosion.
Right. The new preventative measures should eliminate that risk.
This significantly improves our safety margin.
This centralized system really streamlines the underwriting process, ensuring comprehensive financial protection at every stage.
As we can see, adoption barriers like cost and awareness are limiting our deployment and constraining growth. While acknowledging the cost premium and limited energy capacity, flywheels are complementary to batteries, serving roles requiring instant response.